Alright, welcome back to another TouchDesigner tutorial. And in this one we're going to look at how to build a little game inside of TouchDesigner, and we're going to use instancing and the bullet solver and of course some logic in there to make this game. And yeah, this is going to be quite a long video, but I think it's quite worth it because you learn a lot about the bullet solver and some other tricks, like tips and tricks. And yeah, let me just briefly explain what this is about. So basically we have this little 3D platform here, and with my mouse, so far it's my mouse, in the future might be other controllers or sensors, I can control the rotation of that platform. And on that platform there's two things. There's the player, which is like a little sphere, this blue sphere here, which I can't actually control itself, but I can control the platform, and therefore I make it, like with that I make it move. So yeah, as it's based on a bullet solver, it's really like sort of simulating physics. And then we have this coin there that my objective is to collect. So I'm going to move there by moving the platform. And once I collect it, of course it doesn't work again now. Technically there's a little sound coming. And I also get a point, right? So if I just make my way here to the second coin, now you can hear it makes this little sound, and the coin also spawns somewhere else. So I have to again go there, and yeah, now I got lost here. Another thing is if I fall down, it says like it goes red and just says press 1 to restart. If I press 1 to restart, you can actually see it creates a new, like it resets the point, it puts the coin somewhere else again, and it also makes a new labyrinth. So every time I start from the beginning, we have a new generative labyrinth. So the labyrinth is actually based on instancing, based on top instancing. And yeah, you can see there's a few bugs, like sometimes the coin just leaves and sometimes also the ball, if you like move too quickly, the ball like goes through the floor. I don't really know how to change that, because it's like I think that's a bullet solver problem actually, but generally it works pretty well, and it's really a lot of fun to both make and play with, and I spend a bit more time playing with it than I want to admit, but yeah. Alright, let's just get going and make this. Alright, let me just quickly go over the general network so you get a basic sense of what we're going to be building. So we were basically working in two levels. So this is kind of the render level, where we have a camera, light, environment light, and a render top and some processing. And not really much more than that. The main thing is actually happening inside of this bullet solver comp. And let us just take a look inside of that. So this might seem a bit like a lot at once to take in. Let me just go through it step by step. So what we basically have here is 4 actors, some logic, an instancing network, and a light. So the 4 actors are made of the floor, so that where everything is happening on, so the ground. We also have the walls that are based on instancing, right? This little labyrinth here. Then we also have our player, which is just a sphere that's rolling around. And we also have our coin that is constantly spinning, and that changes position once we collect it. We also have a little network up here that is just using the panel mouse position values to rotate our little platform. And we also have like this whole instancing network, right, where we're just making a bit of a grid and then some noise for rotation that we're using here on the walls. And then down here we have our logic part, where we have our keyboard in, where we're like restarting and resetting some things. We also have some collision detection and some detection when the player is falling off the platform. And we also have some materials, and we're going to look at all of this and just build all of this from scratch as usual. And yeah, let's dive into it. All right, so let's start with our render setup. So I'm going to just delete everything and start with a render top. Just gonna put that here. I'm just gonna add a null for now. I'm not really gonna change anything about the render. I'm just gonna add a null and call it BG, as I always do. And what I'm gonna do then is add some more elements to the render setup. So camera comp, a light, and an environment light, right? So the environment light is for the PBR that we're gonna add later on, and you can see this little arrow here. I'm gonna just add a movie file in so we can add like an environment map. Just gonna click on the plus here and select the cloudy ocean. And I'm just gonna add a null just to be clean here and call it like env map. Click on my environment light and I can just add that in here. You're gonna see a little error here. That's because I'm on my laptop and I don't actually have the commercial version on here. So it just says like my resolution is limited, but that's no problem. All right, let me just add 2 nulls here. Just gonna add 1 null and call it look at, and then copy it and call the other one constraint2, not tp2. Actually gonna change the order. On my camera, I'm going to use this constraint2 on the corresponding parameter. Same with the look at. Might want to make these a bit smaller because they're just nulls. Yeah, I'm gonna go ahead and go up with my constraint to like 15. And I'm gonna change my rotation to like -90. And you're gonna see that while we're doing that later on. On my constraint, I'm gonna press C and give this like a white color, and this like the look at a bit of a darker color, because yeah, that just helps me sort of have a nice overview of what's more important, basically. Okay, so that's really it for the render setup so far. We're gonna come back here later on and change a few things. All right, so let's get to the juicy part where we actually add a bullet solver component. So I'm just gonna add that from the comms and then dynamics. I'm gonna just put that around here, make it a bit bigger, give it a red color by pressing C and selecting that. And I'm gonna change the simulation speed to 2 because I've noticed that works a bit better with our setup. So I'm just gonna show you the example that's in here, the default example. So you can just press start, and then you can see the torus is falling onto the platform. And that's because we have 2 actors in here. We have actor 1 and actor 2. Actor 1 is our dynamic actor, so the torus that can move around and fall around and all that. And we have our actor 2, which is static, which is just the ground that our dynamic actor is falling onto. So we want to sort of do the same thing. We want to have dynamic and static actors, but for now we're just going to delete these and build our own. All right, so now we have our empty canvas inside of the bullet solver. So what I'm going to start with is actually not an actor itself, but what the actor is sort of made of, and that's a box. So I'm just going to add a box here and go down with the scale Y, like size Y, to 0.02. So it's really like a thin grid basically, or like a thin sort of platform. And I also might want to change the scale here to 10. Then I'm going to add, by just right clicking here on the output, I'm going to add an actor. And I'm going to give this like a black color. And I'm going to call this floor. And I'm going to turn on update collision shape. I'm going to go to bullet here and turn on display guide. Actually, might want to see that. And we also want to change this to be a static actor. I'm also going to change the collision shape here to oriented bounding box. I noticed that works best and is fastest computing wise. Yeah, that's actually sort of it for now. We're going to style this later on, but for now we don't really need to change anything about this. So if we go back here, we can already see we're like rendering this, or if I go into perform mode, you're not really going to see this because our light is not shining on it. But now we can actually see our thing there. All right, so let's add our walls, right? So this is really quite simple. For now, it's just the floor. I want to add the walls, like the labyrinth, the really interesting part. So again, I'm going to add a box. And I'm going to shape this a bit differently. I'm going to change the size to 0.2 and 0.4. So we get this sort of brick-like shape. And I'm going to actually change the center here to 0.2. And the center here to -0.4. So we're actually pushing it a bit to the side. And you're going to see later, I'm going to explain later why we're actually doing that. It's got to do something with the rotation. So again, I'm going to right click here on the output and add an actor comp. And I'm going to call this walls or labyrinth or whatever you want to call it. So on here, what I'm going to do is I'm going to do very similar things. I'm going to turn on the update collision shape. I'm going to change this to static. And I want to also turn on the display guide. And I'm also want to have this I want to also make this I want to have this Jesus, I'm gonna change this to oriented bounding box. All right. So now we just have one of those, right? And if I just show this, it's just gonna look very strange. We just have this little thing down there. What we want to do now is create a little instancing network to make a lot of copies of these and change their rotations and stuff. All right, so let's go here to instancing and turn this on. And let's create the network for that. So I'm gonna start with a ramp top because I want this to be in tops. So I'm gonna go here and change the resolution to 10 by 10, which is gonna be the amount of instances, right? So we're gonna have 100 boxes for the labyrinth, so 10 by 10 grid. I'm gonna change this to nearest pixel, and I'm gonna change this to 32-bit float. Then I'm gonna add a reorder to this, and copy and paste the ramp. Let's pipe the input into the second ramp and change the second ramp's type to vertical. Then I'm gonna put the ramp 2 into the second input of the reorder, change this to input 2, and now we get this sort of green magenta like texture here. What I'm gonna do then is add a math, and on this math I'm going to change the range here to like -4 and 4, and add a null and call this pause for position, as I so often do. On the walls, I'm gonna use my position here on a translate, and I'm gonna use R for X and G for Z. And you're gonna see this doesn't really work. That's because we actually need to pulse the update collision shape. So now you see we have our 100 boxes nicely positioned next to each other, but it doesn't really look like a labyrinth, right? It's just lines basically, or rows. So let's add a noise with the middle mouse from here. Create a second chain for the rotation channels. So I'm gonna change the output here to just noise. We don't really need to change anything else here. Actually, I might want to change this to nearest pixels as well. And then I'm gonna change this to monochrome off, so we have a colored noise. Then I'm gonna add a math. We're gonna add some more stuff at the very end here. This is kind of where you can have some fun as well. And on this math, I'm going to change my range here to 0 and 360 because we want to be able to fully rotate our boxes. Then I'm gonna add a limit from here, limit top, and add like on the quantize, I'm gonna change this to round, and then to change this to 90. So first off, I'm just gonna bypass this so you see what's happening without the limit. And I'm gonna add a null and change this to rot for like rotation. Then on my instance page, I'm going to use rot on my rotate OP and just use YR. And again, click on pulse, and you're gonna see our beautiful labyrinth here. It just looks really crooked and strange. So that might be something that's interesting to you. But with the limit, and again, we have to update it, we're actually changing the rotation values so there can only be between 0, 90, and so on and so forth, right? So we're just in steps of 90s. And we're gonna look at how to style this later on, how to make different versions of this. Basically, we can just change the seed here, and then we make different versions. But let's have a look at that later on. Let's now look at the dynamic actors. And to start with that, I'm going to add a keyword in down here. And we're gonna actually work a lot with this keyword in. I'm gonna just call this reset. I'm gonna give it a color of green, so it's like an important chop basically. And what I'm gonna do now is split my pane here. So just click on that up there. And on my bullet solver, pressing P, I now wanna change both the initialize sim and collision shapes and the start simulation to be controllable with the reset here, with my 1 on the keyword. So now you can't see it yet, but now every time I press 1, it's gonna start the simulation. So I'm gonna close this. Well, wrong thing, closed. And we're just gonna leave this and come back to that. And now I'm gonna add my player, and for that I'm gonna start with a sphere. And on my sphere, I'm just gonna go to details and go up the rows and columns. And then I'm gonna add a transform. And just go down with the size, like the uniform scale to 0.2, and add my third actor, and let's call this player. And I'm gonna press C and just make this like blue, because we also want to style the actor blue. And then I'm gonna turn on update collision shapes, and on the bullet I'm gonna turn on display guide, so we actually want to see that maybe. So every time I press 1 now, the simulation is going to be restarting. So what I can do now is change the collision shape to, like right now you can see it's set to convex hull. And as you can see here, turning on the display guide, that's a lot of points to compute also, like especially with collision. So it's going to be quite slow in your general setup. So we definitely want to change this to bounding sphere, and that's a lot less points, and in my experience it works just as well. So now if we just look into perform mode, we can't actually see this work well, and that's because our player is like at 0 basically, so it's just going to sort of fall through the ground. So in the initial state, so when the simulation hasn't started, we actually want to put the sphere, like the player, a bit above the ground. So on this transform, I'm just going to put in 2. So if I press 1 now, you can see our sphere is like falling down. I'm also going to like go back here on my camera. I'm going to change this to 15, like the Z. And now if I press F1 again, I can see this whole thing a bit nicer. Actually, I'm also going to change my view to like 50 just to zoom out slightly. And yeah, now I can see this pretty nicely. And every time I press 1, the ball is falling down. But since everything is completely even and there is no rotation, the ball is not actually going anywhere. We're going to look at that in a second. For now, I want to add the coin. So I'm going to add a tube SOP. It's pretty perfect for creating coins. I'm going to change the height to 0.3 and change the orientation to x-axis. If we rotate this around, you can see this doesn't actually look like a coin yet. Let's go up with the rows and columns and then turn end caps on. And now it really looks like a coin. And now what we can do is add a transform, change the uniform scale to like 0.15. And again, we might want to push the whole thing up. So like right now it would be in the ground. So we might want to go up to like 0.4, and we can check out if that's a good value later on. So again, I'm going to add my another actor here, so the 4th actor, by right-clicking here and then just adding that. And I'm going to call this coin. And I'm going to make this bigger and give this a color of pink, because I also want my coin to be pink later on. And right, so again on my coin, I've got to change a few things. So first off, I'm going to turn the display guide on. And you can already see how this is sort of working. So it really behaves like a sort of coin. But in my case, I don't actually want this to interact with the environment. So what I noticed works like best, the only sort of interaction is with the sphere that's rolling around, and they're actually colliding here. But I want to have the sort of logic then that my coin is just like sort of floating around, and as soon as my ball hits it, my player, it changes position, right? So I noticed that it works pretty well just changing this to a bounding sphere. So it's going to behave a bit differently, as you can see here. So it's like rolling around like a sphere now, but it doesn't matter because we don't actually want it to roll around, but it works a bit better with the collision, and it's a bit less heavy, I found, to like compute. All right, so let's have a look at styling all of these actors. All right, so let's start with our floor. And for the floor, we're actually gonna add a PBR material. Right, we added an environment light in the beginning, so we can make use of that now. So I'm gonna just add that and drag it on here, par material. And what I'm gonna do then is just go down with the metallic to like 0.3. Some people have the opinion that that on metallic you shouldn't go in between values of 0 and 1, only like sort of treat it as an on to off, but I don't really care. I'm just gonna add like a 0.15 here on the roughness. And if we like show this now, you can see it's already kind of has this bluish tint. If we actually go down with the roughness completely, you can now see we sort of reflecting the sky. And why are we reflecting the sky? Because we added like this environment map in the beginning of like this cloudy ocean. All right, so that's all we got to do here. I'm just going to change this to 0.15 again. And then on the walls, I'm just going to use a Fong and put that on here, par material. And actually, I'm not really going to change much, just the diffusion to like white. Yeah, that's all I'm going to do there. And then on the player, I'm going to add a constant, in this case, constant material, and just drag that on here, power material. And then I'm going to add a rectangle top. The rectangle, I'm going to change the resolution to be a bit higher, just so the texture looks a bit better. I'm going to put this on here. And I want to change the background color to be blue. I'm going to turn the alpha to 1. And I want to change the fill color to black. I'm also going to go down with the Y size to 0.1 and the X size to 1. Now if we look here, our ball is like our sphere has got this ring around it, right? So we can also kind of see it rotating. All right, let's have another look at the coin. So in this case, we want to add a Fong as well. Put this on here, power material. And now what we want to do here is just change the constant to like a pink color. And now we can see we have like a constant color, but we still like using the light. So it kind of got this shiny look. One thing you may have noticed in the beginning was there was this light around the coin. And that's because there was. So I'm going to add a light and just put that here, right? So what we want to do now is we want to position the light wherever the coin is. Like we have the same position as our coin. Just to sort of test this, I'm just going to change the coin here to 1 by 1. Right, we also have to turn on update collision shape. So now we can see that's the coin is around there. And for my light, I want to have another null. And that's going to be my constraint here. Okay, so I'm going to give my light a similar color to my coins, so we kind of know they're one thing. And what I want to do here on my light is a few things. So first off, I want to have the same color, and so I might just as well go to my Fong, copy the parameter of the constant, and just pass the reference here in my light color. I also want this to have shadows. So I'm going to turn on shadows and change this to be a bit higher, just multiply it by 2. What I'm going to do now is just go to my transform here, translate these, use the translate parameters and copy them. And on my constraint, I'm going to pass these here. And actually, I want to be able to control the Y position independently. So I'm going to just change this to like 0.5. And I'm going to go and select my light and use constraint on the corresponding parameter. So actually, you're not going to see any change for now. And why is that? That's because we haven't actually selected the light here in the render. So on the render, we want to go and just leave the asterisk here because we also still want to select these lights. And then I want to add bsolver1, so this comp here, slash and then asterisk, so for all lights. So now you're going to see it still doesn't work super well. So first off, one thing we might want to do is go to this light, our main light, and go down with the dimmer to like 0.1. And now we can already sort of see the other light a bit better. And now what we can do on this light, we can go to light and change this to distance attenuated and just go down with the attenuation end to like 2. We have to change this 10 to a 0. And then we can actually see now the light is wherever the coin is. So if we now change the coin position, we're actually going to do that on the translate. That's why I used the reference there. And so now we can see the light is shining there. So let's go to the next part and add the rotation, so the control of the platform. Okay, so to have a nice and exact positioning, we want to use the panel values of our panel. So the mouse position values of our panel. So we want to use the panel, the main panel here, right? This one. So I'm going to just open that up so we can sort of see what's going on. So right now it's showing an error. That's because our bsolver, like bullet solver, isn't actually a panel. We have to go back one step further. So we can just type in parent and then just add a 2 here. So we're just going one step further. All right, so if you have a look at here, you can see we already get some channels that are like representing my mouse positions on this panel. So I can just go ahead and select roll U and roll V. And then I can just add another select here. And just copy this. And on the first one, I'm just going to select roll U. On the second one, I'm going to select roll V. And you're going to see why in a second. So I'm going to add a merge here and just put them back together. And what I'm going to do then is add a math. And right now our position values are between 0 and 1 on both axes. So I want to change this to minus 20 and 20. So that's the amount of rotation we want to add to the platform. I might also want to add a bit of a lag to just make it just feels a bit more natural to interact with it then. So I'm going to change this both to samples. I'm going to change this to like 20 and 20 and like just a very, very slight overshoot. So it just makes the whole thing like a bit smoother, as you can see here. Then I'm going to add a rename. And I'm going to rename these channels to Rx for rotation X and RZ for rotation Z. I'm going to add a null and call this rotation. All right, so let's select all the operators, like all the actors that we want to rotate. And actually what we want to do, we don't only want to rotate the floor and the walls, but also the actor. So that is also like takes the height of the, like, so it's still fitting to that rotation basically. So let's go to the X form. So I'm selecting all of them just by control, by shift and then clicking the different ones. And then you can go to X form on them and just use Rx for rotation X and RZ for rotation Z. And now you can see we're actually interacting with this nicely, right? So we can now control this. The kind of problem and the reason why I've made these two different channels is like, it makes sense when I go left and right. It goes like down on the left when I go to the left and same to the right. But like if I go up, like it seems to go down and it just doesn't feel natural this way. So that's why I've just added this channel separation here, and I'm just going to add a math to inverse this by just typing 1 and 0. And now if I go up with my mouse, it just corresponds to my movement. It just makes a lot more sense. That is working nicely. Let's have a look at all the fuck. Let's have a look at the actual logic behind all of this. So we've already added a keyboard in, right? So we can always reset stuff. So let's actually add a few things to this reset, so this keyboard in. So for the first thing I'm going to add here is a count. Oops. And when I add a count, I wanted to use this channel for the seed here. So I'm just going to call this like seed, or maybe like, to be more exact, lab seed, so like labyrinth seed. And because we have this like seed here on a noise, right? The seed value with which we can change the noise, or like the structure of the noise. What I'm going to do is just use this value here on the seed, and it just feels better. I'm just gonna add like a loop min max here and just set this like 1000, because then we're just preventing it from going to like infinity. It just feels better to me. I don't know why. All right, so then what we want to do is actually add a rename here. So just to show you this, actually every time I press 1, you're gonna see we now have a new labyrinth. All right, I'm gonna rename, add a rename and just call this seed again. Because we're going to do a very similar thing, but actually use this on another noise chop. So I'm going to use a count here, and again set the limit to loop min max and then just 1000. And then I'm going to add a noise chop, not connected, but actually just add it here, and change this to samples and then 0. I want to have two different channels. I want to have an X and a Y channel. I'm going to change the period to like 0.1. And on my amplitude and offset, I'm going to set this both to 0.5. So we have an outcoming value between 0 and 1 always. And I'm going to add a math and a null. I'm going to call this null sampler. And on my noise, I do want to connect these, but just by using this number on my seed again. So now every time I press 1, you're going to see also this noise is a different one. All right. So right now it's just showing float values between 0 and 1, and that's not really what I'm looking for. But let me just take a step back here and explain what we're looking for here. So basically, what we want to do is we want to position the coin every time we restart the labyrinth. We want to position it somewhere between the walls. and also every time we collect the coin. But we're going to get to that in a second. But for now, we're just interested in every time we restart the game, so every time we press 1 on our keyboard, we want to reposition the coin. And like the condition of that is supposed to be between the walls. All right, so how can we do that? The thing is, we already have all the positions in this pause thing here. So if you just have a look here, we have a grid with all the different positions. So we have like x0 and y0 here. And then we have all these different things going up to x9 and y9. And then we can like, yeah, we can basically select different samples from here that hold position value. And because we've offset the box a bit to the side, we actually always have like a free space at that position that we can sample from here. So here is the original position, and here we're like offsetting the walls always slightly. So in that way we can make sure that wherever we position the coins, if we position the coins at the exact values that we have here, then they're always between the walls and not colliding with the walls. So how can we do that? At first I thought you could just convert this from like tops to chops, but a better way, apparently, one that works very precisely, is by sampling directly from the pause. So how do we do that? Let me just drag this down a bit more. Let me drag this over here. What we can do here, we can type a little Python expression inside of the translate parameters, right? Because we want to use the position values on translate x and z. All right, so we can just type in op pause and then dot sample and then x is 0 and y is 0. And then we also want to use channel 0. All right, so why is it saying minus 3.6 something? That is because that is the exact value of red, so channel 0, that we have here. So right now we're just saying x0, y0, so we're sampling this pixel, and we're just taking the red channel of that. So let's just do the same thing for z, but with but with channel 1. So we want to use a different channel. In this case, it's actually the same thing, but in other channels, they're actually different values. All right, so so far so good. So right now our coin will always be there, and you can already notice the cool thing is it's always like the walls are always going around it. I'm just pressing 1 over and over again to reset the labyrinth, and you can see the coin is always between the walls, not colliding with them. So, but we want that coin to be at a different position every time we reset, right? So what we have to do is first set up this channel and then use this channel to pick a different x and y every time. So to set up the channel, what we have to do is first change this to an integer, so round. So every time I press 1, now you can see it's a different value between 0 and 1. But what we actually want to have is a value between 0 and 9, right? Because the thing is, what we have here is an x 0 and like the maximum is x or y 9. So what we can do, we can just use like the width here. So we can just use on the range 2, we can just pass the reference here. And actually it's a bit nicer to just type in width. And also what we have to do is subtract 1, because right, our width is 10, but like the values start at 0, so they go up to 9. Okay, so now we get like a different value here between 0 and 9 every time. Now we can just use that here. So now for the x, I'm gonna use a different value here. So op sampler and then channel 0. And then I'm gonna just copy this and put that here instead of the 0 for the y, and just change the channel to 1. Okay, so now every time I press 1, the coin is gonna be at a different position. And yeah, you can see sometimes there is like a bit of a bug there. So maybe we can sort of fix that by just pushing this up a bit further to like 0.6. It's still like some errors sometimes, which I sort of hate. Okay, I think a way to sort of fix that is to go here and go down with the mask completely, and that makes sure that like there's less sort of bugs like that. I think that works. like one thing you might be trying out is also just turning on infinite mass, and then it's definitely not going to collide with anything. But then we're also not actually getting any collision data generally. So I'm just going to go down with this actually 2.4 again. I think that was a bit too high now. So that's it for the different positioning of the coin. Let's now look at how we can detect the collision between the coin and the player. So what's really important here is that you actually go to your coin and you turn off use global gravity. And then what we want to do is we want to add a bullet solver chop. So this chop just gives us a few different types of information about either the entire bullet solver, like different actors inside of it, or just one specific actor. And in this case, we're really just interested in the coin. So I'm just going to put that here, or you can just type it in. And I'm going to change the transform space to actor. I'm going to turn all of this off because we're really just interested in the collision info. So now if I'm like, let me find a good space where I can like collide with the coin. So right now it like the colliding channel here was on. So I'm going to just add a select, and we're just really interested in that colliding channel there. So it's pretty straightforward. It just tells us when it's colliding. And then I'm going to add a trigger to this. And on the attack and sustain, I'm just going to go all down with all of this. So we're like pressing pulse. On the trigger, it's really just a short pulse. And what we want to do is trigger several things with this. So actually 3 things. So first off, we want to change the seed of the noise here. So we want to change the position of our coin. So we can really just use the same system, so we don't have to redo that. So we can just add an override before the rename. The rename is important, so because we have one channel called K1 and one that's called colliding. So if this override changed, like if the input changed because one of the channels changed, then the connection here wouldn't work. So the rename is important for that. All right, so now if I press 1, it's going to be reset. And now if I collide with the coin, it's also going to be reset. So that's already working nicely. And another thing that we might want to add here is a little play, like a little audio play. So with the middle mouse, I'm going to add another. I'm just going to add an audio play. Geez, it's definitely a very long video. And I'm going to go down with the volume a bit. And I'm just going to leave the sound file as it is. So if I trigger it. The thing is, there is a little bug about this. So you could also use an audio file in, but it's much easier with this because it's really made for this kind of stuff where you just trigger short sounds. But yeah, the problem here is that first we want to change this to trigger and like the mode. The problem is like sometimes the first time this is being triggered after a while, it doesn't actually play the file. So I don't know why, but it just be like that. And another thing we might want to add here, so every time now I collide with, no, god damn it, I collide with the coin, and it takes a bit to show you now, it's going to make that sound, right? It's just triggering that sound. And I want to also add an override here, and just use my reset. So you could use another sound for the reset, but this way, every time I press 1, it's going to make that sound, as well as when I collide with the coin. Alrighty, so one other thing is that I wanted to have a score, right? So I'm going to add another count here. I'm also going to use a channel from here to reset that count. So every time I restart, the score is going to be reset. I'm going to add a rename here and just call this score. And I don't actually need to change anything about the count, but every time now I collide with the sphere, technically this is gonna be gonna go up a bit. So like again, now if I collide it, now it's like 1, and then it's gonna be 2, and so on and so forth. So that's just gonna be our score, and we're gonna come back to this. All right, so I'm just gonna go ahead and copy my bullet solver. I'm just gonna type in player here. So we're selecting that. And now I'm not actually interested in the collision. For this, I'm going to use a bit of a more hacky way and use the translation. So basically, now you can see it's going down and down and down into minus thousands. That's because it fell down, right? So right now, if it's like on the Labyrinth, we can see it's around like minus 1.4 or like 0. So it's around the 0 range. So let's just actually select this channel. Let's just select TY. And then what we can do here, we can just add a limit and change this to clamp, and then like -5 and 1. So if it goes like down and down and down, it's just, yeah, we just have like a fixed range here. Then I'm going to use a logic and change this to off when outside bounds, and change this to like -4. So once this goes below -4, so if it's like falling down, as it is not doing right now, but I'm gonna just let it fall down. Then you can see this actually went down to 0. The thing is, usually it's at 1. And when it falls down, it turns to 0. So we want to change that around and just add a math of 1 and 0 here. So basically, it's like now it's like on, and then if it's falling down, then we have a channel that's telling us, all right, now it's falling down, so it's on. And I'm going to add a merge here and just merge these together. And actually, I'm also going to add a rename before this, and let's just call this fell down. Then I'm going to add an out here, so we're like sending that out of the bullet solver to the other level. And yeah, I think that's actually all we've got to do for this. Let's add let's work with these channels. So I'm gonna just add a null here and grab these channels, and yeah, let's just add a few things here to work with that. All right, so first off, what I want to add here is a switch, and after the switch, I'm going to add a text. Then from the render here of the middle mouse, I'm going to add another text. Actually, before that, we want to have a level. And I'm going to put that into the switch here. And on this level, what I'm going to do, I'm going to go down with all of these values and just go up with the low R to like 0.2. So we're like basically just tinting everything sort of red. And on my text, I'm going to just type in press 1 to restart. To retard. Oh my god. Alright. I'm just gonna change the font here to Open Sans and bold. And change the output to comp with input. I change the font size to like 50, so it's just, or maybe 40. Okay. And what I'm gonna do now, select my switch, make this active, and use this channel fell down on the index. So now if I, okay, let's just get rid of the text here for now. If I fall down now with my sphere, let's just try to do that. You're gonna see we're actually getting this little, like it changes to the red and our text. Jeez, it's really not easy to fall down. All right, so yeah, it's falling down, and then we're seeing this. All right. So the other thing we might want to do is use this text here for presenting our score, for displaying our score. Not presenting. Let's turn this on again. Let's change the font to Open Sans as well, also bold, maybe 60 or 50. And let's just change the vertical align to top. So it's like at the top there. And I'm going to use this score on the text. I'm going to type in chop reference. I like select chop reference. And then I'm going to use this int function here around it. So we get like a clean score and not like a float there. Okay, so that's all working nicely. So basically we're done now. Let's now just have a look at how you can have a bit of fun with this and changing the labyrinth and that kind of stuff. All right, so let's go into our bullet solver again. And I already said that in the beginning. I briefly mentioned that we can have some fun here after the noise. So one cool thing is to go to the palette, go to generators and use checker. Let's go to our ramp and right click on here, copy this parameter and pass the resolution, like pass the reference in here onto the resolution. So it's gonna look a bit weird at first. So what we might want to do is change the divisions horizontal to 15. Copy this parameter and just pass the reference here. All right, so we get like this checkerboard. And now what we can do, we can add a comp behind the noise. and then add that into here. And that's already gonna look kind of interesting. But one thing you notice is that this is kind of broken. It doesn't really look like any kind of checkerboard or anything. That's because it actually it's using the second input here as a reference for the pixel format. So if you middle mouse click, we're gonna see, all right, it's an 8-bit fixed. That doesn't really work for instancing. So we have to change this to input 1. And now you can see it's actually working much better. So we could, we can now actually change the composite mode here, like operation to brightest, works pretty nicely. We can also, for example, add a circle after this. So we could just use a circle and that would look like this, but it would never change. But we can also go to output and input this together, and then we get like a sort of circle shape in the center, and then this sort of randomness around it. Also just with noise, again, looks a bit different. So there's a lot of things you can do. One last thing I want to show you in this respect is that you can input, for example, an image, or let's actually just try that. I haven't tried the banana, if that works well, I'm not sure. So we're going to add a fit here. And on this fit, again, we want to, I think I should still have that in here, pass the reference. No. Right click here, copy parameter, pass the reference. And let's just add a composite here. Put that in here. And again, we have to change this to input 1. And yeah, it sort of works, but you can't really see that's a banana. Maybe if we like change the translation, the scale to something a bit higher, maybe we can better see that it's sort of a banana, right? So we might want to change this to something like the butterfly. Maybe we can. It's really hard to see with more complex shapes. Maybe starfish. Well, it's really hard to see, but you can sort of get the idea that this is possible. You can also add your video device in. You can also go to your noise and go ahead and animate this, which is kind of a fuck you to the users, because yeah, if it's animated, it's like you want to go into a certain area and then it's just like the walls are changing. So yeah, it's not very kind to your users, but it's still a fun thing that you can do. Right, and of course you can change like the period here, something higher. You can go down with your with your harmonics, and that also changes the look and feel of what you're doing here. There is of course the thing that sometimes the coin might be enclosed. Let's actually get rid of the animation here. That you can't always reach the coin, but yeah, I haven't really found a perfect way to deal with that. One thing, like with the checker, it's definitely less likely that this happens. So the checker is a nice way to deal with that. All right, damn, that was a really long tutorial, probably one of my longest, but I mean, it's really kind of complex what's happening here, and it's also really fun to play around with. And of course, there's many things you can mess around with. So also have a look at the different actors and what changes if you like change the friction and rolling friction, restitution, these kind of things. Just beware of the restitution. Don't go too high with that. Yeah, feel free to add like other things than just, you know, these kind of walls. Go crazy with the kind of instancing that you can do here. This is really just the basics. You could also add more players technically and spawn them at different locations by changing the initial position here. And of course, more coins and more whatever. You could also, for example, make it more difficult the more coins you collect. That would probably be done in Python then. And yeah, this is kind of buggy sometimes, as you can see here. But yeah, I mean, it's just sort of a good introduction, I'd say, into the bullet solver. So yeah, there's a few things you can try to mess around with, especially on the coin, to try to get rid of bugs. And yeah. So before we end the session, I want to quickly focus your attention on this new emerging YouTube channel that is focusing on TouchDesigner tutorials. And yeah, they're working a lot with Python, with connecting TouchDesigner to like bespoke and similar audio software. And they have a lot of beginner-friendly audiovisual sketches. And they already have quite a nice collection of tutorials that you can definitely check out. So I'm gonna leave the link in the description. Feel free to subscribe and to follow their videos. All right, thanks a lot for watching, and thanks so much for all the people that are supporting me and making it possible for me to do this kind of work and experiment and share. And yeah, I hope you enjoyed this long tutorial, and I'll see you in the next video.